Okay, interval notation. All of these notations go hand in hand. So we're done with the graphs. Do you see how everything is literally inequality signs, open dots, closed dots? Right. So what's going to happen is I'm going to just add a little bit of information because I want you guys to get used to the theory. Meaning I need you to, when you're busy in a test, you kind of have to anticipate what I would say to you in the situation. Okay. So whenever you see interval notation, whenever you see representing a number line, set order notation, there's three things you need to remember. Okay? First thing is we get inequality signs. Okay? Our first inequality sign is this one. This is excluding this. Okay. What inequality sign is that? Excluding. What dot goes hand in hand with an excluding, an open dot? Okay? An open dot. And now added onto that for interval notation, excluding is a round bracket. Okay, and how can you remember that a round bracket goes with excluding? Can you see with a round bracket you can make it an E? Okay, so excluding is going to be the inequality sign without the line, an open dot, and round brackets. Okay. Normally the dots we use for representation on the graph. Inequality signs we're going to use for set order notation. Oh, you must be joking. Oh, no. Now what now? What happens now? Does it still record? Yes. Yeah, it's my husband. Okay. Right, then we have including. Okay, now including is going to be our inequality sign with a line at the bottom, hand in hand with a closed dot, and now it's going to be a square bracket. How do you remember the square bracket? You can make a I. Okay. Any questions? Okay, so the dots we use to represent that on another line, but obviously the inequality sign within that set builder notation lets us know what dot to use. Correct? Okay. So something that's vitally important, grade 10s, is this note over here that says infinity always gets an excluding bracket, and an excluding bracket is a round bracket. The reason being, can you put a value to infinity? No. Okay, that's why we can't say, okay, let's include infinity because what is the value of infinity? We don't know. Does that make sense? Yes. Okay, so very important note. Always an excluding bracket, and an excluding bracket is your round one. Okay. Right, so you guys need to know the difference between all these different notations. For this year, we aren't testing you on this word, but you still need to know what it is. Right. So, interval notation, okay, let's quickly compare. When you represent something on a graph, you've noticed now it could be x is an element of real numbers, x is an element of natural, whole, integer, all depending on where the graph or what set builder notation they're giving us to represent. If they ask you to represent the set builder notation in interval notation, it's always going to be x is an element of real numbers. You cannot represent interval notation for any other number within the number system other than real numbers. So if it said x is an element of whole numbers, you can't represent it in interval notation. Only real have a look at what they give us over here. Okay? They give us, first of all, our first box that we tick. X is an element of real numbers, so we can represent it as a interval notation. Okay, you guys can write this example down in your books. You guys don't have this example. Okay, you guys fine? Next thing, which two numbers do they give you for us to represent? Negative 2 and 4. So that's going to be our two numbers. Negative 2 and 4. Okay, can I continue? What bracket? So do you see how you need to know now that interval notation, we use the brackets. Okay, but now we need to look at our inequality sign to see what bracket to use. What bracket do we need to put by negative 2? It's a including, which is a square bracket. So here by negative 2 we put a square bracket. Make sense? Okay, and let's go see what bracket do we need to put by 4. It's an excluding, so it's going to be a round bracket. And that's your answer. That's it. Okay, so key notes over here is to know which inequality sign goes with which bracket. And for graphs, which inequality sign goes with which dot. Okay, makes sense? Are you sure? Next example, you can write that down in your books. Right, next one. X is an element of? Okay, X is an element of real numbers, so we can represent it in interval notation. Okay. So, what numbers do we have? Only negative 4. So X is less than negative 4. So where is it going up until? Not 0, because then you're going towards the positive side. You're going to negative infinity. Okay, you understand? Because it's less than negative 4, it's not telling you where it's ending, which means it goes towards negative infinity. Okay, so we're going to have negative infinity and negative 4. Do you guys understand? You don't understand. Why? What's the point of real numbers? Because real numbers include everything in the number system. Okay. What bracket always goes with infinity? An excluding around 1. Okay, because we don't know where it ends. And what bracket do we have with negative 4? Also an excluding bracket. So that's how that one's going to look. Okay, you guys understand? Do you have any questions? Right, so for set builder notation, it's used for describing a certain set. Never forget that each number within the number system falls under its own symbol. So at the end you need to state which number system it forms a part of. Okay, so remember I said to you with a number line, if it's a solid line, it falls in which part of the number system? Real numbers. Okay? If it goes in opposite directions, there's going to be an or in the middle. If it's dots on its own, it still lies in between. Okay, so you're just going to have to check if it starts on the integer side, if it starts on 0, or if it starts on 1. Okay. So here, how I would advise, I would start off by first stating which part of the number system it forms a part of. Bless you. Okay, so we've got a solid line. If it's a solid line, it includes all the decimals and everything in between. So X is an element of real numbers. elements of real numbers. If the line connects, it means that x lies in between. Do you agree? Okay, so I'm going to have x in the middle. And x lies in between which numbers? Negative 3 and? Okay, and you obviously know that your negative number always comes first. Okay, another note. If it lies in between, grade 10, your crocodile mouth always needs to face the right. Your crocodile mouth, if it's in between, can never face the other way, and they can never face one another unless there's an oar in the middle. Okay, so if it's in between, your crocodile mouth will always be going to the right hand side. Okay. What crocodile mouth do we have at negative 3, including or excluding? Including, because of our dots, eh? And what crocodile mouth do we have at 2? Excluding, because it's an open dot. And that's it. Okay. Makes sense? Okay, can I do another one with you? Right, so we start off by stating which part of the number system it is. Okay, so it's not a solid line, so it cannot be x is an element of real numbers. What part of the number system is it? Integers, because it's on the negative side. Good job, guys. So x is an element of integers. Does x lie in between? Yes, because it's not two arrows going in opposite directions. Okay? So x still lies in between. If it lies in between, my two crocodile mouths must always go to the right. What crocodile mouth do I have on negative 2? Including. And on 1? Okay, that's it. Negative number always comes first. Okay. X is an element of what? X is an element of real numbers. It's a solid line, it's just going in one direction. Okay. Which means it includes all these little pieces in between. 2.1, 2.2, 2.3, and so on. Okay. Does x lie in between? No. Okay. So we're going to put our x first. X always comes first. You never put the number. Okay. Do you see that my arrow is going towards the negative side? Which means x needs to be less than, right? X needs to be less than whatever this number is. So if the crocodile mouth, our inequality sign, is it going to eat x or not eat x? Okay, it's not going to eat x because it needs to be less than, but it's including less than, because of our dot, 3. Right. The last little bit of work, okay, they're going to ask you to determine between which two integers does the following number lie. Okay, so basically what they're asking you is which perfect square lies before 29 and after 29. Okay, so the first perfect squares being 1, 4, 9, 16, 25. So what's the first one that lies here? 25. So do you see the square root of 25 lies before 29? Okay? That's it. That's correct. And the next perfect square after 29 is 36. Okay, reason being, what is the actual value of square root 29? 5.39. Okay, so this is 5.39. Okay, what is the value of the square root of 25? 5. And what is the value of the square root of 36? 6. That's why 5.39 lies between integers 5 and 6. Does that make sense? Okay, so for example, if I had to say between which two integers does the square root of 80 lie? What you can do is, you don't even know which perfect squares. What is the actual value of the square root of 80? 8.94. Okay, 8.94, which means it's going to lie in between 8 and 9. So basically it's the square root of 64 and the square root of 81. Does that make sense? Okay, that's it, guys. And then you can start with this activity. Okay, yeah, homework. But if you start it now, you'll be done. 3 of these sums that you just did now.